Hello and welcome. This is going to be our lecture video for October 8th. Let's go ahead and get started. So in these pictures below, you do not have to redraw the pictures, but I want you to try to write an equation for each of them to figure out how much does the cake weigh and how much does an apple weigh. So first off, I need a variable to represent the weight of the cake. I'll pick C. What else is on the side with the cake? Well, two more weights. We're not exactly sure what the unit is, but whatever the unit is, these are each worth one of them for a total of 2. Equals, and then on this side I see I've got 25, 26, 27, 28 units. To get the cake by itself, I got to take 2 of these blocks off of both sides. So we used to show this by actually crossing out the blocks. But now we're going to show that mathematically by subtracting 2 from both sides. And then I will get that C equals 26 units. Alright, can you write an equation for this scale? So we need a variable to represent the apples. There's 3 of them. So whatever the weight of the apple is, it's going to be multiplied by 3. So I'll just do 3a equals, now we've got to add these up. I believe there are 15 here, so 9, 10, 11, 12, 13, 14, 15. So now we can't remove blocks from both sides, but we can divide the 2 sides up into even parts. So I could cut this into 3 pieces, and then I could find a way to cut this into 3 equal pieces. Be like 1 cut there. Now that's just got 5 blocks. 1 cut here, that's got 5 blocks, now that's got 5 blocks. Or easier is just to show that we're dividing both sides by 3. I show my division with a fraction line, and then we get A equals 5 units. All right, our goal for today is to be able to use reverse PEMDAS to solve 2-step equations, especially those with fractions, and we'll even get into some multi-step equations. Why are we doing this? Because we need more practice with fractions. All right, here I've got an equation for you to solve. Go ahead and copy it down. All right, in order to solve this, I'm going to first combine my like terms. So the x and the x can become a 2x. The 5 and the 7 can become a 12. Equals 24. Now I'm going to subtract 12 from both sides, leaving the 2x behind. 2x equals 12. And then I'll divide both sides by 2, and I get x equals 6. Once I think it's done, I can put a box around it and plug it back in to double check. 6 plus 5 is 11, plus 7 is 18, plus another 6 is 24. 24 equals 24. It checks out. But now when I'm solving this one, my answer is going to be a fraction. Let's see what we're supposed to do there. So I want to move the constant away from the variable, so I subtract 2 from both sides. I get that 5x equals 21. I then want to get rid of this 5 that's multiplying the x. I do that with division and divide both sides by 5. And I get x equals 21 over 5. I can't complete this division. 21 is not evenly divisible by 5. So you leave it as a fraction. And sometimes you turn that fraction just a little bit diagonal for your final answer. Or you can leave it just totally vertical if you want as well. So x equals 21/5. We like improper fractions when we're doing algebra, so just leave it as an improper fraction. All right, here we've got another one. This one's a little bit tricky because we're not sure what's being done to x here. So let's first do the easy part, subtract 1 from both sides, and we get 4 over x equals 16. But 4 is being divided by x, so what is the inverse operation there? Well, nothing's really being done to x. 4 is the one that's being modified. 4 is being divided by x, so we have to undo that. So we're going to do that by multiplying both sides by x. All right, and I know this seems a little counterintuitive because doesn't seem like that's helping us to isolate x. It's just taking it from one side and putting it on the other. But it does help us because we needed to get x out from the bottom of the fraction. So now I've got 4 equals 16 times x. And now I can actually isolate x by dividing both sides by 16. All right, On this side over here, the 16s cancel, and I'm left with just an x. On this side, I've got 4 over 16, which you might be tempted to leave that as your final answer because 4 is not evenly divisible by 16, but they are both divisible by 4, so I can divide the top and the bottom by 4 and simplify this fraction to be 1 over 4 equals x. And then I always like to put my answers as x equals 1/4. Always bring the variable to the left. All right, let's try another one. Copy it down. How do we get rid of fractional coefficients? So we have 3/4 times the quantity x plus 3 equals 9. So sometimes we distribute in coefficients when you've got parentheses like this, but I don't want to have to deal with these fractions for much longer, so what I'm going to do is get rid of this fraction a different way. I'm going to multiply it by something called the reciprocal. And the reciprocal is just any fraction flipped upside down. So this is right here the reciprocal. And the power of multiplying something by its reciprocal, let me do it over here, 3/4 times 4/3, is that I multiply across the top, I multiply across the bottom, I get 12 over 12. 12 divided by 12 is 1. Anything multiplied by its reciprocal equals 1. So reciprocals cancel out fractions. Now the left-hand side is just x plus 3. These canceled each other out. And on the right, I'll multiply that 9 to the top of this fraction, and I'll get 36 over 3, which can be simplified to 12. So x plus 3 equals 12. Now all I need to do is subtract 3 from both sides, and I get x equals 9. Plug it back in. 3/4 of 12 equals 9. 9 equals 9. Double check complete. All right, another similar one. 42 divided by x plus 6 equals 9. Since we just did a very similar one, maybe I'll embed a question here for you to attempt to answer this one. So embedding the question right here. Okay, let's see if you got it right. I'm going to subtract 6 from both sides. 42 over x equals 3. I'm going to multiply the x to both sides. 42 equals 3x. I'm going to divide away the 3 from both sides. And 42 divided by 3 is 14 equals x. Switch it around, x equals 14. All right, another one with fractions. Copy it down. All right, I do have some like terms here that I can get rid of. Well, at least I can combine. Add them together, the 1 plus 2 becomes a 3, so now I've got negative 5/3 p plus 3 equals 7/9. Let's move this 3 to the other side. I'm going to subtract 3 from both sides. But how do I do this step? 7/9 minus 3. Well, what I have to do is I have to turn that 3 into something with a 9 on the bottom. So I have to multiply it by 9 over 9. So I've got 7/9 minus 27/9. Now I can subtract the tops and I'll get negative 20/9. Back to the problem. Negative 5/3 p equals negative 20/9. To get rid of this, we'll multiply by the reciprocal, so times a negative 3/5 times a negative 3/5. And I get p equals, all right, so multiply across the top, multiply across the bottom. Negative times a negative is a positive, so 60 over 45. Top and bottom are both divisible by 15 here. And we get p equals 4/3. Leave it as an improper fraction. All right, another one where we need to combine fractions. So how do we do this? Well, these can't be combined directly. They need to have a common denominator. So I need to multiply this one by 3 over 3, and this one by 2 over 2. And now we get negative 55 over 18 equals 3x over 6 plus 2x over 6. Notice how I'm bringing stuff that's down in front or behind a fraction just to the top, like the negative goes to the top, the x goes to the top, here and here. And now I've got a common denominator, so I can actually add these. Negative 55 over 18 equals 5x over 6. All right, I can get rid of the divide by 6 by multiplying both sides by 6 times 6 times 6. That 6 will go to the top, and I'll get negative 55 times 6, negative 330 over 18 equals 5x. All right, and then I need to get rid of the 5, so I divide by 5, divide by 5. And when you divide a fraction, you can also just multiply that to the bottom. So now I've got negative 330 divided by 18 times 5, which is a 90. So negative 330 divided by 90 equals x. Top and the bottom were both divisible by 30. So I'll get negative 11 over 3 equals x. Definitely one you want to plug back in to double check here. And how do I distribute fractions? So multiplying by fractions is pretty easy. When you multiply a fraction to a fraction, you just multiply across the top and across the bottom. When you multiply a fraction to a number, you just multiply that number to the top. So now this becomes negative 50 over 6k plus 10 over 2 equals 320 over 9. 10 divided by 2 is just a 5, so I'll just write that that's a 5, and then I'll subtract 5 from both sides. I need to turn 5 into something with a 9 on the bottom, so I multiply 5 by 9 over 9 to get that this is 45 over 9. So I'm going to subtract 45 from 320. 320 minus 45 equals 275 over 9. So now I've got negative 50k over 6 equals 275 over 9. Let's see, is this divisible by 9? No, the digits don't add up to something divisible by 9. Is it divisible by 3? No, it doesn't add up to anything divisible by 3. And I can get rid of the 50 and the 6 in one move if I multiply by the reciprocal, 6 over negative 50. All right, and now the k is by itself over here. I should multiply across the top and the bottom. The negative will go to the top. Actually, I want to show you cross simplifying because it's really helpful here. So what I'm trying to do is 275 over 9 times 6 over 50. I'm going to move the negative up here to the top. I can simplify here and here by dividing these both by 3, turning this into a 3, this into a 2. And I can simplify here and here by dividing both of these by 5. 275 is divisible by 5 and becomes a 55. And this divided by 5 is a 10. I can cross simplify again. They're still divisible by another 5. So that becomes an 11 and a 2. Multiply across the top, across the bottom, we get negative 22 over 6. Oh, and the 2 over 2, that could have simplified as well. Because now I see that this here, if I divide the top and the bottom by 2, I get k equals negative 11 over 3. What's the answer to the last one? Negative 11 over 3. Yeah, what a coincidence. All right, so that's that for this. I'll embed a few more for you to practice here, and have a good rest of your day.